Hi and welcome to DCO. My name is David Copete. If you're new here, what I do is I create parametric design scripts using Grasshopper. This is going to be a full tutorial where I'm going to show you all of the steps for creating this design. It's a wall, a ground plane, and then we create two different arcs with varying sizes and offsets to create this design. So if you want to learn how to create scripts like this, I post tutorials every week where I share with you exercises, techniques, in some cases just work sessions, so you can see the workflow of how it is to create some designs like this. Now, if you want to see how this was made completely from beginning to end, you can also download the script on my website. I'll have that available until the next video is posted. But let me show you a little bit about this design. This design in particular is going to be a wall, the ground plane, and the arcs. And some of the things that we can change are going to be, well, the things that are going to make it the most interesting are going to be the offsets for the arc. So here we have the arc offset of 100. We can make that not so exaggerated by changing some of those sliders. So this is going to make it so it's not so big. Same with this one, we can decrease it. And so part of the subdivision is going to be this triangulated subdivision using isotrim. Then there's also this overhang. So this is going to make sure that it covers the entry and the exit, and there's a bit of shading there. And so the overhang can also be 0. So part of what the reason why I like to use parametric tools for architecture is because as long as you program it with an end use in mind, you can always change your sliders and come up with different designs, different iterations, and therefore being able to see what the extents of the design can do, but also be able to change it and share it with people for them to use it in whatever way they want. So we can even exaggerate this overhang to be like 120 this way. Now the subdivisions, we can also change. We can change the depth of the structure. We can change the depth of the glass. And what you'll see at the end is me cleaning it up. And there's going to be this addition, which is a connection between the structure and the wall. Same here with the ground plane where there's this offset. And so you'll see that here where there's the base offset of 12, we can make it larger, let's say 36, to change it and raise this. So some of those are the cool details that you'll find when you download the script. So hopefully you're interested in seeing how to use parametric tools for architecture. Like I said, I'll be sharing this and all of the steps for creating this. And you'll also see this, which is the cluster. Now the cluster is nothing more than me organizing the entire script. So the same script that you saw in the other file is going to be in here, but this one just has the inputs and the outputs, and it just makes it a lot easier for whoever wants to use this to just adjust these and then be able to take the output, bake it, and then render it and use this as the design. Now, the other thing to keep in mind is that this is just one style of subdivision with triangulated panels, but you can probably take a similar approach using a completely different pattern and develop this in a different way. So this is just one exercise that can show you kind of the power of the parametric tools and also allow you to take those steps and combine them with other types of subdivisions or other steps and make this a custom design for yourself. So thank you very much for being here. Like I said, I'll be sharing with you the entire tutorial, and at the end, you'll see me cleaning it up. So with that being said, thank you for being here, and let's jump right into the tutorial. All right, welcome to the tutorial. Now let's get into the beginning part of it. So let's start with creating the line segments that are going to be the base geometry. So first we'll construct a point using construct point. This is going to give us the location of where the design is going to be. Now the next one, I like to, and you don't have to do this part, is bring in an empty point component. This way I can use this location and I can always change it to a different point. But starting here, now we're going to move into creating the ground and the back wall. So I'll go here to SDL, which is a line segment with a specific start, a direction, and a length. So the direction is going to be in the X direction. The length is going to be how long the line segment is. So depending on what units you're using and what size you want this to be, this would be a different number, or it could be very similar to this. So now that we have this line segment, just know that I'm making the decision to make this created in this direction, so in the X, but you can also do this in the Y direction. Now that we have this line segment, we're also going to create another one that's vertical, and that's going to be the back wall. So I'll take this, copy it using Alt, and then here use a Z vector to create it in the upright position. So this is the base geometry of the design. This is going to determine the height or the base height, and this is going to determine the width of it. Now we're going to be developing the depth of the ground. So using this top line segment, I'll be using an extrude component to bring it down. And when you extrude something, you need to provide a direction. So I'll go here to unit Z. Since it's going to be extruded down, I'll go to a negative component. And then now using this as the input for the base, we can use a slider to extrude it down. So we'll go here to 24. Let's keep it here at 12. Now for the wall, we need to extrude it in the positive X direction. So I'll just bring this, tap Alt, change the Z and the negative to a positive X. Now I'm going a little bit quick here because I want to show you a little bit of my workflow and how I do things. You're more than welcome to change the name. And also if you're seeing things a little bit different than how you have them set up, I have this up here under display, draw icons, draw fancy wires, and draw full names. This way you can see the extent of what's the input is and the icon of what we're trying to do. So now here, now we're going to extrude this in the Y direction, and this is going to determine the length of the design. So I'll extrude it again. So I'll copy, we'll start with the wall, this one. Extrude it. This time it's going to be in the Y direction, positive Y. Now I'll use the slider from here because this has a large number and use that as the input. Now, since we're extruding both the wall and the ground in the same direction by the same amount, now we can take this and copy it and use the ground as the input. This lets you use the slider as the overall length of this. And so it ties it together so you don't have like a different size for the wall and a different size for the ground. Next, we need to create the location of where we want the arcs to go, because the design is going to be 2 arcs and one in the middle that varies. And so what we need to do is, well, first we'll hide these because it's redundant with the extrusions. And then we'll go to our line segment back here, and we'll have to create and get the endpoint from this and move it to this location, because our line segments are going to be here and then the other one's going to be out here. So let me show you that. The component we need to get the endpoint is going to be endpoints. And this will give you the start and endpoint. So I'll actually extract just the endpoint because I know that's the start, that's the end. And when you bring in this component, it actually gives you both at the same time. So one way just to extract one of them is using the endpoint as the input. And now we're going to be doing the same thing to this. Well, we also have this start point from here. Now we're going to take this and move it in the positive X direction by the same amount as the wall. So what I'll do is bring in a move component and use that same X vector of 12 to move it in the positive direction. And now it ties it. So I know that that point's always going to be located at the top of that wall on the inside. Next, I'm going to be getting the endpoint of this line segment. So I'll go here, copy this down because this creates the endpoint, and I'll be using this as the input. So now we don't have this previewed, but if we preview both this one, which gives you the start and end, and we see that this is the one that we extracted. Now we have both the start and end points. So I'll bring this here. And so we have it matching. I'll copy this one, plug that into it as well. Now it's a bit redundant, but we're just keeping things clean and organized here. So now that we have these 2 points, now we need to move them to the end here. And since we already have the overall length determined by this Y vector, we're going to be moving, let's see if we move these down a little bit. We're going to be moving, so we'll use the move component, use the point as the input, and then move it by using this vector. Same thing down here. So all we're doing is moving the points to the end of the design, and this will allow us to create a line segment between the start and the end point. So this is the start point for that line segment. Here's the end point. We'll use this as the start point and this as the end point. The reason for this is we also need the midpoints. So for now, let's bring those out. We'll bring in a mid curve middle, which is the midpoint. And same thing with this one. All right, so now we need to create an arc between these two. But let me show you the component we'll use so you understand why we kind of need to set this one up. So we have the start, this point, and this point. We have these two, but the arc is asking us for 3 points. And this only has 2 points. So what we'll do is set up the arc to have 3 points. And so to do that, there are different ways we could do it. We can create a line segment between the start and end point. Then create a midpoint. But if we were to use these as the arc 3 point, notice that the midpoint is going to be point B. The first one is going to be either one of these points, and this is going to be the last one. It just creates a line segment because there's no variation in the point here.
So what we need to do is I'm going to scoot this over where the midpoint is for the center. And I'm going to offset this line segment. So I'll go here to offset curve. And I'll be using a slider here to determine the offset. So I'll go here to 15. And I'll just vary this. We have it parametrically with the slider, so we can always change this. And use this as the curve middle. So when we offset this, now we have the variation, which is going to allow us to create that arc. Now we need to do the same thing to the endpoint. So what I'll do is create a copy of this arc, use this one as the start point, which is the end one here. This one that we moved all the way to the end as the end point. And now we need to offset, or first create a line segment between the two. So I'll use a line segment between the start and end point. And then use an offset. So I can copy these. Use an offset and a midpoint that share the same offset. And use this midpoint rather than this one, because right now we're sharing the midpoint. This will be the other point for the middle. So with this, now we've kind of set the stage to create the curve in the middle, which is going to be the same idea, but it's going to be a different offset. So I want to show you a trick that I used, which is if I've already created the steps, then I don't need to recreate them because I can just copy them. So I have this line segment that's been offset that has a midpoint. Well, what I'll do is I'll take this and I'll copy the slider as well, so I don't have to create a new one. Now I'll use this midpoint and this midpoint as my start and end points. I'll change the slider maximum. And I'll create a new arc based off of those points. I'm trying to keep this organized so you see exactly what I did. I also have this available so you can download it and see how it plugs in if you're kind of lost or you're fairly new to this. So now we'll copy this arc. We'll take this point as the start, point A. We'll take this point as point C and use the midpoint as point B. Now notice that this middle one is going to be changing. And so now that we have the steps already created, let's go back to the offsets, select them. You can middle click and disable preview all at the same time. Trying to keep this organized so we can see all the wires where they plug in. Here's the trick that I use. I select these, go to midpoint to this one, and it organizes them vertically, and then to the right to organize them to snap to the right. Now we have the midpoint, the end, and the start. So let's bring in a loft component, plug in this arc as the start, this one as the next one, and then this last arc as the last input. Notice that we can change that arc. All right, so now with this lofted surface, technically we could divide it, but here's the issue, is when we create this arc in the middle, it takes that loft and it subdivides it into like these different segments. And we don't want that. We want this to be a smooth surface so we can subdivide it any way we want. So to do this, we're going to rebuild this curve. We'll go to curve, rebuild. We'll plug this in as the input. Now, I want to rebuild all of them at the same time. So the way to do this is double clicking on the input for the loft, because those are all going into the loft. Now we'll plug in all of those at the same time into the rebuild curve, which will allow us to then change some of the inputs here. Now, we're not going to do that because since they're arcs, it's actually fairly easy to rebuild it with this one without having any other inputs, although you could. And then use this rebuild curve as the loft input. So what you'll see here is now I'm just hiding the input for some of these line segments that are overlapping. And so at this stage, this kind of takes care of the base geometry, which is going to be, for the most part, the important thing, right? From here on out, we're just going to be taking this and modifying it further. But this gives you a good idea of how you can use simple steps to create a complex form like this one. Now, on the next portion, what we're going to do is first modify an overhang. Then we're going to be offsetting some of the inputs, like the line segment here, to be offset to the inside. And then we'll be subdividing the entire thing. All right, so the next step is going back and looking at the way we created this. We do have this midpoint. So let's go back to this midpoint. We don't have to show these other two midpoints in this line segment, so I'm just going to disable those. And now with this one, now I want to move that in, well, we'll start with this one, in the positive Y direction. So here's the trick that I use is double click here to create a relay. I'll double click here because we'll be doing it to both of these. And now we're going to interject in between this output and that input. I'll move this one, this point, midpoint, in the Y direction. And I'll use a slider. And do the same thing to the other point in the negative direction. So now this slider determines the overhang of the design. And now we can change the point B for both this one and from these two to these two. So we're creating a modification for the offset and then the modification for the offset on this one. And now we don't have to do that to the middle one because the middle one is the arc that these two need to go through. And so it's important for it to be centered here. This overhang is going to help because when you have an entry or an exit, this is going to ensure that You don't have any water or any rain or any elements. It has also some shade. So that kind of completes that portion of the design. Now, let's look at where this starts. Notice that it starts right at the edge, and that's okay if you're going to offset it to the inside, but we're offsetting it to the outside to give it a thickness, right? Because the surface doesn't have a depth. So when we offset this now to the outside, this has a place for it to sit on, which is okay. But this one down here does not, because when we offset it to the outside, it'll be hanging out in the middle of the air here. So what we'll need to do is take that line segment or those points that create this arc and move them in the negative x direction. So in the same way that we did here, where we moved it in the positive and negative y, well, in this one, we just need to move it in the negative x. So I'll bring in a move component, a negative component, and then x vector. We'll start with this one. I'll double click on the output to create a relay. Then move this, we'll say 12.5. And use this as the input now. And notice that since we started with this point and we moved it out there, and that's how we created the line segment to the midpoint, it technically moves the entire bottom portion of that in. So depending on how you program your scripts, sometimes it'll be easy like this, but in other cases, you may need to move each point in the negative x direction. So now with this, you're saying that we created those modifications, and now we've kind of set the stage to be able to develop this in any way we want. So let's go back and let's clean this up a little bit. And what I mean by cleaning it up is let's hide the input of things that we don't have to see, we don't have to look at. This way we can have a clear direction of where we're going. So hide all of these arcs and most of those inputs, so we can just focus on now developing this. Now, if you're new here, what I'll be doing is using the default components that come in with Grasshopper. That way you don't have to go and download plugins, and because sometimes that gets a little bit confusing. But if you are a little bit more experienced and you have used other plugins like Lunchbox, you could use other plugins like Lunchbox here and use the panel subdivision to subdivide this in different ways. With that being said, let's go back and use our typical components to subdivide a surface, which is going to be isotrim. Now, isotrim by itself doesn't work unless you bring in divide domain squared, which will allow you to subdivide it in the U and V. So we'll be using the loft surface as the input for the domain, the surface, and then the segment is going to go into domain. By default, you'll see that the U will be 10, the V will be 10. And so we'll, for now, use two different sliders of 10 and 10. And then, you know, we can change the number of subdivisions we have here. Oh, this doesn't have the input. I'm like, why is it not working? Okay, so now this one determines the direction in the U, the subdivisions in the U, and this one in the V. And so when we divide something using isotrim, Notice that it still maintains the arc portion of this, which depending on how you would develop this, that could be okay. But typically these would end up being straight line segments. So to do this, we're going to now take this surface, we're going to deconstruct those panels and recreate them using a polyline going through all of those points. Now I can show you that just by picking one of them, but actually let's do that. We'll take those isotrims, we'll go to list item, which lets you pick just one of those panels. Now I'll hide everything else, including this one. And notice that this is composed of 4 different points. So if I take this and I deconstruct this BREP, which is the boundary representation of this, now we can take those vertices, which are the points that create that surface, and create a polyline that goes through those vertices. And those are going to be straight segments. Now we can also take this and close it. So closed, set Boolean to true. And so although that creates a closed polyline, notice that it won't create a 2-dimensional plane. To do that, we can develop it in 2 different ways. We can create a midpoint and create 4 panels in the middle, or create a diagonal here. So that's what I'll do is I'll delete this polyline. We have 4 of these vertices, but now I want to just pick 3 and create a triangle. So I'll go here to list item, because we know we have 4 vertices, but they're all contained inside of this output. So I'll go to list item, plug this in. We have the first one, the second one, which is this one. When you zoom in far enough, you'll be able to add another one. So the third one, and then the fourth one, right? You can also use a point list to know how they're organized. But now we're going to go through 1, 2, and 3 with a polyline. So the first one, the second one, and the third one. And then we'll go to closed, set Boolean to true. And now we're going to do the same thing with this one, but we have to go the first one, the second one, then the third one, and then the fourth one. So I'll copy the polyline. I'll just start with another one here just to show you and not confuse you. So starting with the first point, skipping the second one, going to the third one, holding down shift, and then going to the last one here. So now we can go to closed, set Boolean to true, and we've redeveloped that panel into 2 triangles. Now we can change the direction because this is index of 0. So if we go 0 less than 1, it'll give us a slider of 0 and 1. And now this will let us change the direction. So 0 is going to be the default, and then 1 is going to be the other way. So now when you have a polyline composed of 3 points, we can create a surface, a boundary surface on those polylines. And now what I'll do is I'll hide. Well, first, just know that since we did it to one panel, we can technically do it to all of them at once. So I'll take this and this, hide the input, and then I'll go here to list, and then I'll go to graft. So now we've basically redeveloped this surface into these triangles. And we can change the direction that they are located or that they are divided. Now this is a lot easier to develop because we have a triangle here, and so on. And we can also change the number of subdivisions. So we'll keep it here at 5. Just do 8 and 8 here. Now what I'll do here is go to the end portion, take these and join them together. So I'll go to brep join. I'll plug in both of those surfaces into the input and flatten the input. This way we have just one open brep and we can hide the rest of the steps. Now what makes parametric modeling really cool, in my opinion, is that we can always change these inputs depending on what we're looking to do. So what I'll do here is, now that we have basically this set of steps after we create the loft, what it does is it creates the subdivisions and then the triangulation here. We're now going to be creating the depth of the design, which is going to be offset to the outside, and creating the frames that create the structure or the main structure of the design here. All right, so with the triangulated subdivisions, instead of joining them here, what we're going to do is I'll double click here to bring those into just one surface component. This is going to contain all of those triangles. Now what we're going to do is create the frames, which will determine the structure here. So we'll take this, we'll bring in an offset curve, but this one is going to be offset on surface. For the inputs, we're going to use the surface as the curve input because the perimeter is going to be a curve, and then the surface itself is going to be where it offsets. So now we have the offset. Now by default, it's going to have a number here, 1. Let's change that and have the ability to pick the frame size. But also, what I'll do is I'll copy this down here. I'll unplug the distance on this one and right click it and go to set number to 0. This way we have the original curve, then we have the offset, and we're using the same component. This makes it easy and lets Grasshopper know that they are the same type of curves. Now with these two, we're going to create a surface. So I'll go here to boundary surface. And I'll create a boundary surface between the offset and the original. So now here, you'll see that we can pick the offset. And this is going to give us the frame size. Now I'll take the surface and disable the preview. And since we need to create a thickness to this, because technically this is still a surface, like a plain surface without any depth, what we need to do now is offset this original surface. So I'll bring this down. Offset this.
And let's use a slider to offset it. So we'll go here to 6.5. Notice it's offsetting to the inside, so we're going to offset it to the outside using a negative. So now it offsets to the outside. So as you see here, we have the stage set because we've done all of this. We've created the subdivisions, the frames, and everything down here. So what I'm going to do is copy all of these steps except for the sliders, because the sliders will be the same for both of them. So I'll take all of this. I'll deselect the sliders and take all of this and copy it up. So I'll slide it up, tap Alt to create the copy. And I'll move all of this over. So now we can use the offset surface as the input for the copied version of it. So of course, it'll do the exact same thing where it subdivides it, turns it into a triangulated subdivision, and then offsets it into a frame. So what we'll do is hide the input for the original ones. And now we'll need to connect both the offsets. So using a loft component, we'll use the offset ones first. And holding down Shift, I'll add the other one. And we'll be doing the same thing to the outside ones, or the original ones. So this, and holding down Shift, the next one. So we've created the frames, then the offset frames, or the original frames, the offset frames, and then the connections in between. And now let's go here to join, bref join, and plug all of these in, because since they're all grafted, they will all be organized. And as the output, we have 128 subdivisions. I'll disable the preview on most of the stuff we did before. Clean this up a little bit. And just to test to see if it works, I'll middle click and bake. And notice that now all of these are their own triangles and they are square sections that can be developed. So I'll delete that bake and then come back here and I'll go to the offset. Let's offset this a little bit more. Now let's go back to the frames and let's first go to our offset frame, the original ones. And let's also go back to the other ones that we offset. So what we're going to do now is take those frames, turn them into surfaces. So I'll go here to boundary surface. Disable the preview on the rest of the portion of the design, and then extrude these down perpendicular to the triangle, basically creating a depth for the covering of this. Now what I'm seeing here is that we first need to offset this original frame to a specific location and then connect those two. So we'll go back to this offset. and we'll create another offset. So we'll move this up, create another offset. This offset will be by less. So we'll just make this one half. We'll do 4. And now we'll do the exact same thing, but we don't need to copy the outside ones, which are these. We'll need to copy this one and all of the steps that we had before. So basically, since we've already taken care of this, we could just copy this and not the sliders. And use this surface as the input. And then this, I didn't override that one. So now we have the frame here, and that's going to be determined by this slider. So now let's take these two frames and let's loft them together. So now that we have these two lofts, we don't have to use this surface, but we can use a cap holes on this one. And it'll create a top and a bottom and turn this into a solid. So now we've taken care of the structure and the glass cover. Now to organize this, I'll use a geometry component that's empty. I'll group it, and by default I have it as green. And I'll do the same thing with this one. Now I could use a custom preview. And a color swatch to kind of give it some color and materials. I'll turn this one blue, and then the opacity, I'll make it 50. And then I'll disable the preview on the geometry here so we can see through it. And now we'll do a custom preview for the frames and use a color swatch for it. I'll take this and just copy it over to the ground. Make this a 50. And then the wall will be a little bit of a different color, maybe a little bit lighter. And I'll disable the preview on this portion. So now you're seeing that here we have some glass, we have the structure, and this is all fully created here parametrically within Grasshopper. So if there are any portions in which you got lost or you have any questions, let me know in the comments below. Like I said, I'll have this available on my website so you can download it and see how it was plugged in until I post the next video. And yeah, hopefully you learned something and are excited about learning a few more tricks here within Grasshopper. And yeah, I hope to see you on the next one.